Hi, am I audible? And my slides are also visible, right?
Yes, ma'am.
Okay, let's get started with this week's problem solving session. So this week we are discussing some basic concepts of R. This is the third week. So those of everybody, please make sure that you have installed R and R Studio on your laptop. I'll just I have already put the link in the chat box, so you can go there and start the download. Meanwhile, while it is downloading, we can discuss whatever was covered in the lecture. And there are a couple of announcements from the instructor of the course. The first is that for your exams, there won't be any R access. It will just be a MCQ type of pattern. But there will be some MCQ questions that are based on R. So you won't be writing any R codes, but uh, today we'll be discussing some MCQ questions based on R. So those type of questions you'll get, and all the R codes that are in the lectures and in the same codes we will be discussing in the TA session as well. So those are available in the NPTEL portal. Otherwise, you can download from this web page. So I have put all the links in the chat box. So please download R Studio and all the codes for week 3. So you can start the download. Maybe it will take some time. So meanwhile, we can discuss what was covered in the third week. So week 3, first lecture was about getting started with R and how to install R and how to install R Studio. So I hope you have watched the lecture and you have installed already. If not, you can start the download now. And in the 15th lecture, some uh, logical operations and basic arithmetic operators were discussed. So in logical operators, we have the comparison operator such as equal to equal to. It will compare if two numbers whether they are equal or not. And then exclamatory mark equal to means not equal to. And then other basic symbols like greater than, less than, greater than, equal to, greater than, or less than equal to. So these will give a value of true or false. And there are also logical operators like and or not. So these we will discuss in more detail when we are discussing the codes that we discussed in class. So now I'm just giving a brief overview of whatever operators are there in R. And there are also some basic arithmetic operators like addition means you have to use the plus sign and minus or hyphen sign for subtraction and the star sign for multiplication. And for exponent, you can use double star or this tilde sign. And so there's one more operator called a modulo operator. So to do the modular operator, you have to use the sign percentage percentage. So it will give the remainder of the division. And if you do a normal slash, it will do a regular division. And if you do percentage slash percentage, it will give a integer division. So the difference is that in regular division, the final answer will come in decimal point, but in integer division, the final answer will come as a integer value. And in week 3, we discussed reading and writing data. So like if you have data in any Excel file or any CSV file, then first you have to read the data into R. So for that we use read.csv. So this we can discuss in more detail with when we are running the codes. And then in the next 17th lecture, we discussed descriptive statistics using R. So in this lecture, we learned how to get some basic statistics such as mean, median, variance when we have a data set. And then in the 18th lecture, we discussed t-test and ANOVA and R, how to perform t-test, how to perform ANOVA, how to check if the data is normally distributed or not, how to check if the data is having equal variance or not. Based on this, we have to choose which test to use, whether we have to use t-test or ANOVA. So this also we can discuss in detail when we are running the codes. And finally, the next lecture was based on linear algebra using R, how to get the inverse of a matrix, how to get transpose of a matrix, how to solve linear equations using R. So these were discussed. So first we can discuss the MCQ questions. So that by the time you have downloaded and installed R and R Studio, then after discussing the MCQ questions, we can go to the running the codes, the live practical session. So those of you who are still downloading R Studio and the codes from week 3, can you please raise your hand? So is anybody still trying to install R and R Studio? If anybody is still trying, then please raise your hand. Okay, so nobody has raised the hand. So I hope then most likely all of you already have R and R Studio installed. And so I hope you also know where to find the codes that were discussed in the lecture. So those are the codes that we discussed in the lecture. Same code we will be running during this practical session. So do you all have the codes as well? So if anybody does not have the code, can you raise the hand? I'll put the link in the chat box and you can download from there. Okay, so I hope you all have the code as well. Okay, somebody has messaged that you don't have the code. So I'm putting the GitHub link here. So in that, for every lecture, the code is there as a compressed file. So you just have to download the file and decompress it. So I have given the GitHub link code. You can download the codes from there. Okay, so meanwhile, while you're downloading all the codes, you can just put it to download and meanwhile we can go to solving the MCQ problems. So this is the first question. Which of the following function is used to read a CSV file in R? You can type that answer in the chat box, then we can discuss the solution. Yeah, the correct answer is A. So A, So to read a CSV file, we have to use the read.csv function. And here in the bracket, we have to give the file location. So this we will discuss in more detail when we run the codes. So the correct answer to the first question is option A. So let's go to the second question. So there is a code that they have given and you have to write what is the output. So when you're typing the answer in the chat box, also type the answer along with the question number. Yes, so most of you have got it right. But only I think few of you are answering. So everybody, those who are in the session, please try to solve and answer the question on your own. So the second question, they have given a code in which for X they have assigned the value of R. So this symbol greater than hyphen symbol. So this symbol means assigning in R. So different programming languages will have different symbol, but in R you have to remember this symbol. And why they have assigned the value of 10. And in the third line, they are saying the value of Z will be whatever is X plus Y. So it's just a simple addition. So 10 plus 3 is 13. So the final, when you are asking it to print the Z variable, it will show 13. So for the second question for the second question, the answer is 13. Let's go to the third question. This one is not as straightforward as the others. So you can take 2 to 3 minutes, then we can discuss the solution. Yes, so the correct answer to the third question is option A. So let's discuss how we got option A now. So here they have given two matrices. Um, so the first matrix they are defining as they have defined the two columns of the first matrix. So the first column is 1, 1, and the second column is 1 minus 1. And the second matrix also it is having just one column, which is 2, comma 0. So matrix M is 1, 1 and 1 minus 1. And matrix B is 2, 0. And we have to solve. So in the R code, they are asking to solve this. So this will correspond to X. This row will correspond, this column will correspond to X, and the next column will correspond to Y. So solving just means so we are trying to solve this. Um, so if we matrix multiply and write it in equation form, it is x plus y equals 2, x minus y equals 0. So from you can cancel these two plus y, like you have to, when you add these two, plus y minus y will be cancelled. 2x equal to 2, x equal to 1. And when you substitute x equal to 1 here, you will get y equal to 1. So this matrix is will be the answer, which will be 1, comma 1. So that's why this matrix is S. So S is equal to 1, 1, or option A is the correct answer. So now let's go to the next question. So I hope this third question is clear to all. If you have any doubts, you can raise your hand anytime. We'll discuss it and then go to the next question. So these are the type of questions you can expect in your exam. So you won't be asked to directly write codes or run any R codes, but these kind of questions will be given. So you have to know what will each of the R functions be doing. Yes, so you have, some of you have got the correct answer. The correct answer is option D. So here the first code will generate a um, vector. So let me just write here. My whiteboard is visible to all, right? Because that's where I'm writing the solution. So the first line is sequence 292. So this means it will start a sequence which is starting with this number. This is the starting number. This is the ending number, or the sequence will be less than this 9. And this is the um, gap or interval between the numbers. So this U will be a sequence of numbers or a vector starting with 2. And this gap is also 2. So we have to keep adding 2, 2, 4, 6, 8. And we are stopping at 8 because the maximum value is 9. But if you go on, the next value will be 10. So, but that can't happen. So this is U. And V they have given directly 1, 2, 3, 4. And W they are saying is U plus V. So W will be, we just have to do a vector addition. So the first number will be 2 plus 1, 3. Second will be 4 plus 2, 6. 6 plus 3, 9. 8 plus 4, 12. So this is the W vector. And they are saying Z is square root of W bracket square bracket 3. So this W square bracket 3 means third term of W. So third term will be, this is the first term, this is the second term, so this is the third term. So W is square root of 9, which is 3. So the final answer is 3. So in some of the programming languages, the vector will, the like numbers will start with 0. For example, in Python, if you write the same W of 3, then it will be, this will be it will start with 0. So this will be 0, 1, 2, this will be 3. So this is in Python. But in R, the number will start from 1. So the first 3 will correspond to the first index. This will be the second, third, and fourth. So this is the system in R. So in Python, if you write 3, then the value will be 12. But in R, it will be 9. So those who are already used to Python, you have to make a note of this, that in R, the indexing starts from 1, not from 0. So I think otherwise, if this is your first programming language, then I think it won't be confusing. But those of you who have already used Python or MATLAB, you have to just remember this, that the indexing will start from 1 in R and not from 0. Okay, so now does anyone have any questions? If not, we can go to the next question. Okay, we can go to the fifth question. So the slides are just loading. So you can take 1 or 2 minutes to answer this, then we can discuss the answer. Yes, the correct answer is option C. So here it is based on the summary function. So if you use the summary function, it will give the value such as the minimum, yeah, minimum, maximum um, number of NAs. It will also give the median, but it will not show the variance. So so fifth question was fairly easy. So I'm showing the sixth question now. It's based on logical operators. So most of you have got the answer correct. The sixth question, they have given a value for A is assigned the value 10, B is assigned the value of 3, and C is assigned the value of what is the outcome of this operator. So if you look at C, the first term is A equal to 10. So that is true because A is assigned true. So the first term is true. But the second term is B equal to 2, which is false. So if you do an AND operator of true and false, it will be a false because it is AND operator. So the correct answer is option B. So I hope it is clear to all. Okay, if there are no doubts, we can move to the seventh question. Yes, seventh question is it's a very direct question. So they are asking which function is used to calculate number of elements. So for that, you have to use the length function. So the correct answer is option C. So let's move on to the last MCQ. So this is also just which which function will give the transpose of a matrix. Yeah, so to get the transpose of a matrix, we the function that is used is T, and in the bracket you have to write what is the matrix for which you need the transpose. So yeah, that's it for the MCQ session. So now let's go to the R sessions. Um, Let me just open the files and share my screen with you. Meanwhile, you can also open R and R Studio. So I'm opening the code for lecture 3, week 3. So I hope all of you have already installed R and R Studio, and now you can open lecture 3, week 3 codes, and we can run it line by line and check the outputs. So now I hope you can see my R Studio screen. So I'm starting with the first file of lecture 3, week 3. So in case any of you are not having this file, I'm just going to copy paste this code and put it in the chat box. So you can just paste it in yours and run the code, okay? So you just have to open RStudio, and I am putting the code in the chat box. Just paste this code and we can run it line by line. Those of you who have already downloaded the files, you can open it from the file directly. Those of you who don't have the file, you can copy paste from the chat box. Okay, so can someone confirm if my screen is showing the RStudio code? Can you see my RStudio? Okay, great. So you're able to see it. And it will be better if you also do it side by side with me. So one basic thing is that in R, this hashtag means that whatever is written after the hashtag, it will not be written as a code. So it is called as commenting. So it's used to write what is done with the code so that there is no confusion later on. And in R, you have the option to run the code line by line, or you can also run it entirely. So if you want to run it entirely, you have to select everything and press this run button. Or if you want to run it line by line, if you want to run the first line, you can keep the cursor in the first line and press run. Or the So when you do it, these codes up to 1 to 8 lines have not run because they are having the hashtag. Directly it has gone to X. So here you can see in this console window, which is the line that has been run. So this 2 to 10 is the line that has been run. So in this line, X 2 to 10. So we have created a vector X, which is having the value starting from 2 to 10. So to check what are the values in X, you can either type, so one option is you can type print X here and you can select run, or instead of run going and clicking every time, the keyboard shortcut is command enter for MacBook and control plus enter for window. So if I type print X, the output will come here. So in R, all the outputs will come on the console window in the bottom. And whenever we declare a variable, that will get added to the right side of the R window here. So you can check there as well. And so you can check the variable here on the right side, or you can, when you do print, you can check it in the console at the bottom, or you can also check if you just type the name of the variable and type enter. In that way also you can check what is present in the variable. So we have ran these two lines. So now let's go to the next line. Here we are defining a new variable y with using the sequence function. So sequence function we just saw in the PowerPoint, that presentation as well, on the um, MCQ question. So this will be the starting number and this will be the increment value. So first number will be 1.23, second number will be 1.23 plus 0.5, like that. And it will go on until the value is 6.9. So if you want to check what is the output, you can type print y and run it. And if you check the console, so the code is starting from 1.23 and then it has added zero point 0.5 to get 0.73. Again, 1.73 plus zero point 0.5 is 2.23 and it has stopped at 6.73 because if you do the next value, it will be greater than 6.9. So it has stopped here itself. And if you notice in the right hand side, we have defined a new variable y, so that this new variable has also come on the right hand side. So these are the different types of creating a list. So a list is a list is like a series of numbers is called a list data type. And here we are seeing all the different ways of creating a list variable. So now let's run this ages code, ages line. So here we are defining a new list with the name ages. So here we have used the C operator. So if you use the C operator, then whatever you are giving inside the value will be the value of the list. So you can check what is the list of ages by typing ages here, 18, 19, 22. So basically whatever is inside the variable it has taken. So whatever we have created so far is a list of numbers. Now we are creating a list of, um, so you can also create a list of strings. So whenever you use a string, so string is like basically like an alphabet. So it can be alphabet or it can be a combination of alphabets and numbers and so on. So to define a string, you have to use this uh, code. So whatever is inside the code will be considered as a string. So now let's run this line. And now we can check what is within the names list. So basically, whatever is inside the bracket has been taken as the values. So this was the lecture 3, week 3, first part. So now I'm opening the second code, which is lecture 3, week 3B. So this code also I'm copy pasting for those of you who don't have the code. So you can just paste the code into your RStudio and run it. But this is based on this iris.csv data file. So that you have to download from, it's available on the GitHub page. So you can, that I'm not able to put on the chat box. So you can download that. And the code, in case you don't have it, you can copy paste from here. So in the first line, we have to read the iris.data CSV file. So to read.csv file, the main input that you have to give is the what is the CSV file, and you have to give it as a path name. So if you just write the name of the CSV file, then the computer will not know where to find the file. So for example, if I run it, then most likely I will be getting an error. So, but anyways, I will try and show you. Okay, so actually for me, I think I have already loaded the data because I was running this code already. That's why it is coming. Otherwise, you have to get the file path. So to get the file path, you can, so for if you're having a MacBook, then to get the file path, you have to hold the option button and right click. And from there, you have to select copy as path. And for Windows, you have to hold the shift button and right click. From there, you can select copy as path. So now I'll also enter it as a path. So just so you know how a path will look like. So a path means it will be separated by these slash variables. So in the desktop, so each slash is representing each folder. So within the desktop, you have to go to temp. Within temp, it is there in this file, this folder, code data lecture 3 folder. And within this folder, the name of the file is iris.csv. So in my computer, it is stored in this path. But in your computer, wherever it has been stored, so that path you have to enter. I'm running this line. So this data has been loaded here, as you can see, and you can also see it by clicking. And if you want to check what is in the top half of the data, then you have to use the head function. So in the bottom, you will get the output of the first about 5 to 6 lines of the table. So it is having it is having 4 columns. No, sorry, it is having 5 columns. And if you want to check what is in the last part of the data, you have to use the tail function. So here totally there are 150 rows. So you are seeing the last 6 rows when you use the tail function. And if you want to check the variable names, then you can use the names function. So it will give what are all the column names. So it's having sepal length, sepal width, petal width, and variety. These are the columns. So everybody is able to uh, read the CSV file and run these lines, right? Otherwise, you can raise your hand. Okay, so I hope it's working for all. And if you want to check the dimensions, like how many rows and how many columns are there, then you can use the DIM function. And number of rows, you have to use n row. So it is saying there are 150 rows, and number of columns is the function is n col. So there are 5 columns, like we already counted. And if you want to check the structure of the data frame, so structure meaning how many values are there in each column and what is the data type. So that information you can get from using the structure, and you have to write the file name in the bracket. And now suppose from this big data frame, you just want one of the columns, then you have to first write the name of the data frame and dollar symbol and name of the column. So here the data frame name is iris.data dollar and name of the column is sepal.width. So if you run it, you have taken this as SW. So you can, yeah, and on the right hand side, this SW has come now. So you can also check it by typing it or by printing it. So just one of the columns has been assigned to SW. So this is one way of, if you know the column name, you can use the dollar symbol. But if you do know only the column number, then you have to use the square bracket. And the first will be the row number, second comma, and the second will be the column number. So here the first number is empty. So it means we are selecting all the rows of the second column. So let's run this and we can check what is in D2. So you can do print D2 or you can type D2 in the bottom console. So same thing. This is the second column is sepal width. So this is the second column and all of these values of second column have been assigned to D2. And if you want to extract 2 columns, then again same, you're extracting all the rows. So the first place will be empty and then you have to write comma and 2:3 means so from the second column up to third column will be selected. So let's run it and check. So D23. Let's see what is there in this D23 by using the print statement. So here you are getting 2 columns because we have selected both 2 and 3. So this is one of the methods. And now from this data, if you check the data, so then there are 2 types of, in the variety column, there is setosa, right? So if you just want the rows in which the variety column entry is setosa, then you have to use the subset function. For the subset function, the first input will be the which from which data frame you want to make this subset. And then the second input will be which on based on which column you are separating it. So here we are separating it based on variety column. So in whichever entry of the variety column is equal to setosa, only those will be assigned to d dot var. So now let's run this. and check it using the print statement. So initially in the first data frame, so if you check the iris.data data frame, here there are 50 rows, but in the original data frame there were 150 rows. So some of the rows are having Virginica as the variety type, so those have been removed. Some of them are having versicolor, so all those have been removed, and whatever is having setosa, only that is included in the this using this subset function. And finally, so here it is, here also we are using the same subset function, but here we are only choosing those values where the petal length is greater than 1.5. So here we have written petal dot length because this is the column based on which we want to make a subset, and we have to write, then after that we have to write the condition. So we have run it, and let's check what is in this d.par.pl. That is, I'm just typing the name of the variable. So there are only few columns that have few rows that have petal length greater than 1.5, and these we have filtered out separate. So this is the second code from week 3. Let's go to the third code. So I'll again copy paste it to the chat box. Okay. So in this second code, what we are doing is we have now made a subset file. We have now made a subset of the original data frame. And from this data frame, suppose we want to save it as a file, then you have to use the write.csv function. And here the first input will be the name of the data frame that you want to save. And the second input will be the file path that you want to save. And row.names equals false. This we are giving because in this only we are having column names, but we are not having any row names. So row.names we have assigned as false. So when you run this code, this will be this d.par.pl. This will be saved in this whatever file path you have inputting here. So you can run it and check in your computer whether it has been saved or not. And we can also use a print statement to check whether the assignment has been done properly. So this is the third code. So I'll open, I think for week 3, there are 4 codes. Yeah. So this is the fourth code for week 3. I'll put this also on the chat box so you can copy paste the code. So far, whatever data we have been reading was from whatever file we already have in our computer. But there are some data that you can access from the internet directly. So there you have to give the, okay, this line is still based on the old data itself. So in my computer, it is not in this file path, but anyway, I'll try to run it and we can see what I get. So if you give the wrong file path, you'll get this kind of a message. So it is saying no such file or directory. So because in my computer, there is no C folder. So I have to change the file path correctly, whatever is there in my computer. So now I'm going to wherever the file is, and if you have a Windows computer, you have to press Shift and right click. Then when you right click, you will get an option as copy as path name. So you have to copy, and that value whatever is copied, you have to paste. And all the file paths have to be within these double quotes. So now if I run it, I'm not getting an error. The data has been read properly. So this is one of the way. And the second way is you can read the data directly from the internet. So for that also we are using the CSV function, but instead of giving a path name, we are giving a URL or the sorry website where you can find it. So this also has to be within double quotes, and the website is already given here. So if you run it, this online dot data has been read, as you can see from the right hand side. So it's having these two columns. And so far we have been reading CSV files, but you can also have another file type called text files. So to read a text file, you have to use a different function called read.table. So read.csv will not work here. You have to use read.table. And yeah, this tab.data has come on the right hand side. So it has been read by the R. Okay. Yeah, let's go to the middle. And there are some of these data files that are already within the RStudio package. So if you want to check what are all there, you have to use the data function. And suppose you want to load it, because it's already coming within the RStudio, you just have to write whatever name of the data set you want. So for example, here we have a data set called BOD. And if you want to load it, you just have to write the file name that you want and name of the data frame that is there. So this bod.data has also been loaded into our. That's it for week 3 about how to read data, how to um, write data. So let's go to the week 3 lecture 4. So we have covered week 3 lecture 3 now. So in lecture 4, week 3, there are two codes, A.R and B.R. So I'm opening A code first. So this lecture 4 is, this lecture was based on finding the descriptive statistics for mean, median, variance, etc. So I'm copy pasting the code in the chat box. You can paste it into your Art Studio and run it. So here first we are making a new data set ourselves by giving these three columns. Ages, systolic SYS means it's basically like blood pressure data. So SYS is systolic pressure and DIA is diastolic pressure. So I have run this. So the ages has been assigned now. So you can see from the console what in the below. And next, SY has also been assigned and DOA has also been assigned. Now, if we want to know the length, then we can use the length function. This we just discussed in the MCQs. And if you want to know what is the out of all these values, what is the minimum, then you have to use the min function. And similarly, max function will give the maximum value of the vector. And these are all just different functions. So median will give you the median. And to get the mean, you have to use the mean function. To get the variance, you have to use VAR. And ST will give the standard deviation. And all these values are displayed in the bottom in the console. Yeah, so now these three values, ages, this and dia, these three vectors were separately defined as three separate vectors. But if you want to club them, make them together as one data frame, then you have to use the data dot frame function and give all of the vector values that you want to combine. If I run this, then now we have created a data frame called bp.data. If you want to check, you can check it with the print statement. So if you print it, now it is printing all three together as a single data frame with the three columns. And you can also check the summary. So when you run the summary for each row, it will display the summary statistics. So this is lecture 4A. Now I'm running lecture 4B. So I'm copy pasting the code into the chat box. Now let's run it and see what we are getting. If you're first again, we are reading the file. So in R, whenever you are reading any file or any variable is created, it will all get stored in the R environment. If you want to like delete it, suppose your computer is getting too slow and you don't want R to keep it in the memory, you can just press this clear button and all of these will be removed. So I'm running a new code, so I have removed whatever was in the R memory. And now I have to, because I have removed it, I have to read the file again. So I have read it and this has been saved in the R uh, memory now. Now we are getting the summary. So for each column, it will give the summary statistics. And now we want to calculate the mean petal width, but not for all the columns, like not for all the flowers, but only for those flowers that are of the versicolor type. So to do that, first we have to make a subset from the main data frame. And after making the subset, we have to calculate the mean of the petal width column. So here we are making the subset. First column is the name of data frame and second column is the condition that only the versicolor flowers have to be considered. And here we have to find the mean and they are saying mean of the petal width. So we have to just choose the petal width column and find the mean for that column. So to choose column, we are using data frame dollar column name format. And to check what is the value, we are using the print statement. So the mean petal width we are getting 1.326. And now we are going to draw the frequency distribution of petal width for plots. The frequency distribution of petal width for all the flowers. So for that, in R, to get the frequency distribution, the function name is this. And in the bracket, you have to write for what variable we need the frequency distribution. Here we need it for petal width from iris.data data frame. So in R, all the plots will come in the plots window here on the right side bottom. Now we have plotted the petal width distribution for all the flowers. Now, if you want it only for rosy color flower, we have already made the subtype here. So for that subtype, we are taking the petal width column and making it histogram using the list function. Okay, this is the new histogram. So this is what we discussed in the code for lecture 4 of week 3. Now let's go to lecture 5 codes. So I'm putting the code again in the chat box. So you're all able to run the code slide. Okay, so we still have some time. If you're able to run the code, then can you run through the Shapiro screen and type in the chat box what output you're getting, whether you can take a couple of minutes to run the code yourself. And I'll see I have put the code on the chat box. So in the Shapiro.test line, whatever output you're getting will be sent in the chat box. Then I'll show you how to run. the code running for you. Actually, are you able to run the code? That means if you are not able to run it, so I'm showing from the beginning because I was already having the file. I was opening the file directly. But yes, in case you are not having the R files, then go to R Studio and find, create a new file. That type you have to select R script. So you will get an untitled script open with this. And so in the chat box, I have put the code. So that code you have to copy the whole code and paste it here. Now, if you run this from the first line, just on the top, there is this run button. So if you press it, it will run instantly. So here it is asking, you have to choose plant.csv. But I'm getting an error that there is no such file or directory, so I have to give the correct file path. So if you are getting this error, then you have to go to the file where this plant.csv file is there. So in case you don't have the file, I'm sending the file also in the chat box. You can download the file and use it. These files are also available on the GitHub website, or you can download from the chat box directly. So you have to go to the folder where the file is, and then for MacBook, you have to select Option and right click. For Windows, Shift and right click. Then in one of the options will be copy as path name. So select that. So now the path name is copied. Here you have to go and paste it. So I hope till now it's clear to all. So now are you able to run it? Rakshana, are you there? Gopi Krishna, are you able to run the code?
Yes, yes, ma'am. Yes.
Oh, you're able to. Okay, great. So now we have read this data frame into this, read the CSV file into h.data. And we can see for each column what is the mean, median, etc. So we have in h.data, we are having two columns. One is treated and one is untreated. Now, suppose you want to see what is the difference between the treated and untreated column, the simplest plot would be a box plot. So you have to use the box plot function for that. And the first two are whatever um, axis you need for the box plot. So the first axis will be the untreated column, and the second will be the treated column. And so we are plotting two boxes. So for the two boxes, we have to get the x-axis in. So that you have to give us a string. So see, or sorry, give us a list. So to create a list, we are using the same function. So the first x-axis we will be y-axis unfiltered, second x-axis we will be freezing. So this is the second input we have to give to the function. And the third input is, so we have given the x-axis name. Now next we have to give the y-axis name, which will be height of plants. And we can also give a y limit based on the maximum values. So here you check the summary, the minimum value is around 62 and the maximum value is around 150. So with a little bit of gap, we are giving the y-axis limits as 60 and 150. And you can also choose the colors. So here we are just giving, so now let's run it. If you run it, you will get the plot here. So now it looks like in the treated plants, the height is more than the height of the untreated plants. But now we want to check whether this difference is statistically significant or not. So for that, we first have to choose what is the type of test we want to check. And that we will decide based on whether the data is normally distributed or not. First, we have to check whether the data is following normal distribution. So for that, we have to use Shapiro test. For that, we can use the function Shapiro.test. For we have done it for the untreated column. We are checking for the treated column. So in both the p-value is quite high. It's coming as 0.3726. So these are not normally distributed. Now next we have to check whether the variance is equal or not. So for that we are using the variance dot test function. So the null hypothesis says variance of the two samples are equal, and the p-value that we are getting is 0.5. So based on this, we can choose which test to use. So we are to check whether these two, the difference is statistically significant or not. In the next line, we are using the unpaired two sample t-test. So here the null hypothesis is that the mean of the two samples are same because in your t-test, we are comparing the mean of the samples. So this is the null hypothesis. And based on the p-value that we get, we can accept or reject the null hypothesis. Run this test. Here we are getting the test results. So the main result is the p-value, which is 0.150117. So the p-value is very small, which means that we can reject the null hypothesis. So if we reject the null hypothesis, then what we get is mean of treated samples not equal to mean of untreated sample, which means that the difference is statistically significant. This is the first code of lecture 5, week 3. So lecture 5, week 3, we have one more code. So here we are loading a data called plant growth, which is already within the loaded in R, so you can directly load it. Let me just clear this whatever we have. So in D, the plant growth has been loaded. And now let's check what we have in this D data frame. So we have weight and 3 groups. So Now, suppose we want to visualize what is in this, then we can do a box plot. So in the box plot, since they have given, there are three types of groups. So those will correspond to the three columns. So weight is corresponding to the three groups in the data frame. And the data is this D, what we have loaded. And we have given the y-axis name. And here x-axis name we have not given separately because it is already given in the group. And we have chosen a color, etc. So we have got the box plot, and now we want to check whether these three are different or not from each other. So whenever we have more than two groups, then it is not recommended to use a t-test. We have to use a ANOVA for that. So to use the ANOVA, we can, so we are doing a just a one-way ANOVA here. Which so when since it is a one-way ANOVA, this is our hypothesis that all three means are equal. So to do this, we are using this function one-way dot test. And the first is which three groups we are comparing, which is the weight of these three different groups. And the data is from the D data frame. And we are assuming equal variance for ANOVA. So if you run it, the ANOVA test results are saved here. So let's see what is the result. So the p-value that we are getting is 0.015. So typically the p-value cutoff is 0.05. Some people keep it less than that also. So if you keep 0.05 as the cutoff, then this p-value is lesser than the cutoff. So you can reject the null hypothesis. So which means that the means of the three groups are not equal. So that will be our conclusion from this. So this is lecture 5. Sorry, I will skip the code here. Now let's go to the code from lecture 6. So lecture 6 is based on matrix operations and linear algebra. So this we have already seen how to create a vector using the C functions. And if we print it, whatever values we have given will come. And one more way is using the sequence function. So this will be the starting value, this will be the interval, and the middle number will be the maximum value. So if you print it, you'll get 12 plus 8, 20, 26, 8, 28, and so on. And if you want to choose any from, because a vector will be having many numbers, if you want to choose the third number, you have to use the square bracket. And here we are adding 2. So if you add 2, then initially the first number was 1, now it has become 3. And 3 has become 3 plus 2, 5. 5 has become 5 plus 2, 7, and so on. So in R, when you add a scalar to a vector, it will, each element of the vector will be added by the scalar. And you can also add two vectors, u plus v. So now the u value has changed here. No, the u value has not changed. We have given it a new variable. So the first one will be 1 plus 12, so 13. And the second will be second number of u's plus second number of v, which is 3 plus 20, so it will be 23. So you are doing a element wise addition. And scalar multiplication, we all know all the numbers of the vector will be multiplied. So the A is so also the 12 has become 24, 20 has become 40, and so on. And we can also do a dot product by using this. So in the library, first you have to load this library, which is having the dot product function. Yeah. So when you do a dot product of two vectors, you will get the final answer will be a scalar. So this you can check whether the value is correct or not by doing it manually yourself. And you can also get the magnitude of a vector by using the norm function. Um, and one more way is using the square root of x square plus y square formula. That's what we are doing here. We are doing square root of the sum of u square, which is basically like doing square root of x square plus y square like x square. So, and when you do this or when you use the norm function, you are getting the same answer. And to get the unit vector, I hope you all know unit vectors. You have to divide the vector by its magnitude. So, if the vector is u divided by magnitude is norm. So, when you do that, you will get a unit vector. And for a unit vector, the definition is that the magnitude of a unit vector is 1. This lecture 6 goes. So if anybody doesn't have these R files, let me know. I'll paste it in the chat box. Otherwise, you can directly open the file from your computer. You have already downloaded. Okay, so this this code is about matrices. So we are first creating a vector using the C function. And now from this B vector, we have made it into a matrix. So this C, if we print D, these are the D values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But here we have made it into a matrix by making it as two rows. So this 1 and 2, this 1 is going as first row, this 2 is going as second row. Same way, first row, second row. So based on that, you are getting a matrix like this. And if you check the class of the matrix, you will get matrix here. And one more way to get a matrix is by combining two vectors. So here we have two vectors D and D. So if you do C bind, then each of it will become a row or a column that we can specify in the function itself. Here we have not specified. So the default is it is becoming a column. So initially T and D were two separate vectors. Now they have both combined to give a matrix. So if you do C bind, then they will be combined as columns. And if you do R bind, they will be combined as rows. And now we are doing more matrix operations by loading the BOD data frame file. And if you check the data frame file class, it is a data frame. And if we print it, it has two columns, time and demand. And the class is, of course, matrix. And we are removing so initially these column names were there. Now when you add this line, column names, we are assigning as null, so the column names are removed. And if we want to select the third row, second column element, then we have to use the square brackets with row comma column. Select it here. And if you want to select the entire first column, then the row column has to be empty. Only in the second column you can write 1. And to find the transpose of a matrix, you have to use the T function. This, if you remember, we discussed in the MCQs. So initially the function was like this: 1, 2, 3, 4, 5, 7 was the column. But now 1, 2, 3, 4, 5, 7 has become the row because that we have taken the transpose. I hope this is clear to all. Any doubts in this? Or can we move to the next code? Okay, I hope nobody has any doubts and everybody is able to run the codes as well. So I'm opening this file, lecture 6, week 3, C. So this is the third code of lecture 6. So here we are, this is an important part where we are going to discuss how to solve a system of equations. So this is based on the question that we discussed here. Yes, so this is based on the third question of this assignment problem solving session that we discussed. So to first solve it, we have to write it in the form of Ax equal to b, where A is the coefficient matrix, X is the variable matrix, and B is the right hand side matrix. So these are the equations we are trying to solve. X plus y equal to 6 and minus 3x plus y equal to 2. So here A will be the coefficient. So in the first equation, the coefficient are 1x plus 1y, 1 comma 1. And second equation, the coefficient are minus 3 comma 1. So A will be the first equation 1 1 and second equation minus 3 comma 1. And so the final form is Ax equal to B. So B is the right hand side. So in the right hand side we have 6 and 2. So that is why here we have defined B as 6 and 2. And based on this, let me run the code. So we have defined based on the coefficient of the variable, and B is the right hand side. And now to solve it, you just have to use the solve function. And now if you print it, you will get the answer is x equal to 1 and y equal to 5. So we can check. If you substitute x equal to 1, y equal to 5, 1 plus y equal to 6. So the first equation is satisfied. And second equation, minus 3 into 1 is minus 3 plus 5. So minus 3 plus 5 is 2. The second equation also is satisfied. So it has solved it correctly. One more option is we can also try solve it using the inverse. So x equal to A inverse multiplied by B. So when you just do print of solve of A, it will automatically consider that B is an identity matrix. So this will give you the inverse. And now if you want the solution, you have to multiply it with B. And in this lecture, we saw how to multiply two vectors. is the third one. Where we have discussed how to solve a linear system of equations. Yeah, that's it. So does anybody have any doubts in this? If there are no doubts, we can finish the session for today. So I hope all of you were able to run these codes. Does anyone have any doubts? If there are no doubts, we can finish the session for today. Okay, then let's end today's session. We can meet next week again for the next session.